All right, everybody. Thanks for joining today's CISL seminar. We have a virtual speaker today that's dialed into the seminar, and so we're pleased to have him here with us today. The topic is Agentic AI in Action, Building Reliable Multi-Agent Systems for Research Data Workflows. And joining us today is Keven Guan, who's the lead developer and research scientist at the organization Florida International University. He works with the GIS Center as well as the FIU libraries. And he's a research scientist and lead developer at the GIS Center within FIU libraries. And his work sits at the intersection of agentic AI, research data management, and large-scale cyber infrastructure. And he focuses on building reliable, production-grade, multi-agent systems that coordinate large language models with persistent memory, governance rules, and executable workflows. So I've been working on a project with the integration of NCAR's data services with the Open Science Data Federation, and that's how we were introduced to Kevin's work at FYU, and I found it of interest, especially to those of us that deal with data curation, and just if you have any interest in how agentic AI workflows and coding works in general, I think this should be of interest. So thanks so much for joining us today, Kevin.
Thank you. Thank you for the opening and introduction. Good afternoon, everyone. Here they introduce, this is Boyuan Keven Guan from FIU GIS Center. Today's topic, I slightly changed a little bit. So I'm going to focus on trustworthy agentic AI from production failure to engineering solutions. Just to start with, I would like to have one of these opening slides talk about trustworthy agentic AI system, which must be reliable, auditable, and the governance under real-world constraints. It's not just capable. In that sense, today I'm going to focus on pretty much two dimensions of how I build a system solution to maintain a trustworthy agentic AI. So pillar one is about reliable agents, which is agent level trust. I'm going to focus on how do we make a single agent reliable over time, including explicit behaviors, structured domain knowledge, reusable, auditable skills, controlled learning adaptations. The solution, we call that dual helix plus three-track architecture. And pillar two is about reliable systems, which is a system trust. How do we prevent failure from cascading across different agents, which is solution including role separation, privilege isolation, audit handoff, human in the loop boundaries, which is the solution in that sense is a multi-agent system. Here's the outline about today's talk. I'm gonna cover the motivation, like when agentic AI fails in production, and also gonna cover two following section about pillar one, reliable agents, and pillar two, reliable systems. And then the last session will be kind of open discussion, open directions. For in general multi-agent system in agentic AI solution for research data management. So I can start with the motivation part. I'll briefly just introduce what this project in MA Store about. To starting with, MA Store is an NSF funded project. The main purpose is it give a we set a pretty universal level storage. Currently, we're hosting 2.7 petabytes. Dedicatedly serve as a universal storage for research data management. On top of that, we do have different components for computation, data federation, visualization, and also for discover. Each of this system consists of FIU HPC Center, branding as Raptor, Pelican and OS Pool taking care of the data federation, ArcGIS Online for geospatial data visualization, and Dataverse for discovery. The problem is when we present this platform to the research group in FIU, it's hard for them to kind of move forward with a platform like that. It's not their like a daily work to learn how each component works. The learning curve is there. And we're trying to go with like a traditional data pipeline way with scripts. However, when we deal with currently we're dealing with over 30 research groups in FIU. Their data schema, data format, metadata, and domain knowledge are varies a lot, which make the traditional scripting type of I'll say rule-based system not work. You need to like customize each of them for each group or each data set, and then we try just purely AI agent dump everything to a ChatGPT type of solution is still not working and is not stable. And then we come up with this type of smart data pipeline. We implement this pipeline at the early stage of 2025. Um, and we kind of retired that by September 2025. Just by looking at this chart, you can see from the left side, the input will be sort of data lake, and it's still following a traditional data pipeline way. And the way we bring the large language model as a role here is we're just replacing a node with a large language model, uses capability of reasoning, generating code, and auto smartly choosing the decision and with a curated tool set. So this is kind of it's not a tradition, but I'll say like a beginning stage how we use Gen AI as a task executor to replace a traditional deterministic system. And then when we implement that into production, we notice some failure mode. First and foremost, of course, I believe a lot of people have here must experience that whenever you have a Gen AI component in your system, you're dealing with inconsistent in production. The output is non-deterministic, which means if you give an identical input, it does not guarantee identical actions. And in reality, the same task and same agent, it will not necessarily give any certain same result. That's generate problems. And also there is generate like a run-to-run variations. The first run, it works and it might pass your test with many runs, but still when in production, the second or third run might just give you a hallucination or refuel or just formatting errors. So the root cause is whenever you deal with or you bring in a large language model into your workflow, the large language by itself is stateless exaggeration, and also each language model have a limited context window. By use that context window for different tasks, it causes context drift. As the conversational history grows, the model attention maximum lose focus on original constraints. So that's caused a problem. And there's no explicit governance. This is kind of like the nature of language model. Then I believe some of you have already tried existing method, which like prompt engineer, few shots prompts. Even you can build a rack system to give different reference for the language model to check. We have tried the same thing, and we also build like we call that three-track framework to do the context engineer. However, at the time we tried that, we noticed there's sort of sweet spot when you bring the Gen AI as a component for your system. So that's something, I would say that's something new when you think about this paradigm shift from traditional rule-based system to a Gen AI type of system, because language by itself is based on probability. We can try as much as we do, in our case, as shown in this chart, some of the tasks like intention analysis, data cleaning, data schema awareness was the AI agent we built. With all the method we have been applied, we can reach a correctness to 90%, which is pretty good. And we know that we can push forward. We can push it to 95, 98, 99. But trade-off is the more you're pushing the number to go higher, you lose the intelligence. Eventually, you can go 100%, which means you just end up with a chatbot with everything defined in the backend as a dictionary, like a rule base. The language model will check your vocabulary or dictionary and do everything mechanic. Then back to the question, what's the point you want use a language model? You still want keep a certain level of intelligence and self-awareness, conscious, and make decision for you, right? Then I'll say there's a engineering constraint and a trade-off. You need to keep the balance. In our case, a good agent in our workflow is the agent with roughly like 90% of accuracy. That's kind of comfort zone. Is pretty good and stable, but it also keeps some of flexibility to deal with your question with its own knowledge base, its own sort of reasoning capability. And then by having that in consideration, it gives another problem, which is why a single agent smart data pipeline will break in production because the error propagation, the security coupling, and also independent verification is still there. Here is just high level abstraction from the left side of our smart data pipeline. It just go with ingest of data, cleaning, normalization, metadata generation, and publication. So several steps. And there of course, there's like a sub task in each task. So roughly there's like 20 to 30 steps, micro steps for a language model to take over. And here, very simple math is if you ask a, let's say, just the best agent we have developed so far with 90% accuracy, the arrow is just pass forward in each steps, which is the formula is here is 90% to the power of n representing the steps. That means just roughly after 10 steps, the accuracy dropped to 34%, which means if you keep going with your single agent pipeline, mathematically, we can prove it will make a mistake almost like for sure eventually. So that's like the system level. When you have a single agent in the pipeline, it will not deliver stability or trustworthy solution for your own workflow. Then the production failure just reveal like two distinct problems. One is agents that are naturally unreliable individually, and then systems that are unreliable even with good agents. That's kind of the problem we find in production implementation and the motivation for build the current system we're using. And the next section I will start covering, which is the pillar one, the reliable agent, also known as the agent level trust. Here is just if we zoom in just to the agent level trust, we can focus on failure modes of RLM-based agent in long-run system. In that sense, I will kind of categorize that into exaggeration, non-determinism, under context drifting, unbounded action space without governance constraints, attention degradation and knowledge fragmentation, absence of persistent and structured memories, and also objective myopia and local optimization bias. I think the first four is kind of common. And the last one, if you're not get a chance to actually work with agents, in your daily work routine, you may confuse what I mean by objective myopia and local optimization bias. So I give kind of a example on the right. I know that the text might be too small to read. So the condition is on a specific kind of typical day work. I'm kind of build a graph database, and I know this graph database have some problem like missing links or mislinked between different nodes. Roughly, there are I think 150 or 140 some nodes. So I just ask my agent that, hey, look, there's a graph database is pre-built and there's some missing links and misrelation between the nodes. I want you to read each nodes, understand what's this node for, rebuild the link among different nodes. For me, it's I kind of know that within the context window of the task, the agent should be able to just fix that. So I leave it running and I just step off for dinner and come back in 2 hours. What happened when I come back? I do see the result. There's a visualization of my graph database. I can see everything is connected. There's no mislink. Uh, but I also noticed that the whole graph shrink a lot. It's not 140 or 50 anymore. It's like roughly 50 to 60 nodes only. So obviously something wrong. So I kind of go back to see the log being printed by the agent while it's kind of working on this. And it's pretty interesting when I see the log, as you see on the side I put there, the agent is taking the task and start talking to himself. He said, wow, the graph has 147 broken links. The original graph are full of cross-reference between tasks, but they are using different IT format and that doesn't match, which is correct, which is the root cause for the problem. And then the agent kind of starting analysis problem and giving himself two options. Option one is let me fix all the broken reference, 147 of them, which is tedious. And then the agent give himself option two, which is just show the internal connection within each graph and ignore cross-link for now, which means it do zoom into this specific request, which is get rid of missing links, but it kind of ignore the original request, which is fix the graph database missing links problems. Then that's how I see when I come back in 2 hours, the agent just show me a smaller group of graph with everything well connected, but get rid of all the nodes, which is very risky in production. I mean, later on, I'm just saying, oh no, don't do that. Just create a rule for yourself. Always check with me if there's like multi option for each task. So this is like a typical case agent can go wrong when the objective myopia and local optimization bias happens just for a single task. And then when we know this kind of like the failure mode, we want to build a system like a Agentic AI agent that has persistent memories, externalized memory that give documents, graph, artifact, so it will not lose memory. And the agent should have structured tool exaggeration with state tracking and validation. And also the agent should be able to inexplicit or reactive planning capability within a single interaction. And then the agent should have expertise, which is domain-specific competence with via curated knowledge and reusable skills. And also, which is very important, like what saved me in the previous slides is everything produced by the agent, there should be a way we can audit. So we can know like right away something go wrong and we can check. So this is kind of the design purpose in a single agent level, how we can deliver a trustworthy agentic AI solution. To formalize, this is kind of core components. Domain knowledge, which answer a question like what is a dataverse, which GIS database are stored in shared infrastructure, behavior and rules, something like require human confirmation before destructive action, like I just showed a slide before. The skill execution, which is like a deploy front-end service, retrieve credentials, copy artifacts to production. And then, of course, you need actual tools like Python scripts, Git scripts, Postgres, email service that the agent can execute upon with. And then here is the actual framework, which I call that three-track engineering knowledge architecture. You can think it's part of the actionable framework for context engineering. So track one, behavior, like the governance layer, which can define communication protocol, code quality standards, safety and authorization rules. Track two is domain knowledge, which is a semantic layer that kind of include the system architecture, core concept, components, relations, and track three is the actual skills, which is step-by-step procedures, preconditions, and the access check. Of course, requires scripts and environmental variables. And when we implement that into systems, pretty much your system will look at this like three components. On the top is just whatever solid large language model you choose, can be GPT-4, 5, Cloud, Sonnet, Gemini 3.0, 3.0 Pro. Even you can go with open source family like Llama, whatever you choose. And then the center box is the expansion of the large language model with the context engineering framework we just introduced with three tracks. You kind of connect the language model to your behavior rules, the skill what you just defined, and also the knowledge. Then whenever the language model just execute a tool, it will guide it by the knowledge you provide, and also it will be bounded to the behavior rules. So it will what I mean by bounded is when they see like multiple options, the language model should know, let me stop and check with a human collaborator before I make something wrong. And then the output will be a reliable domain AI agent with consistent outcome, expertise for domain knowledge, self-involving, and high quality skills to make actions. So there are two arrows I want mention here. One is this system is just quickly adapt to evolution in the whole Gen AI industry. That means on the top, whenever there's a new language model appears and appear to be more suitable for the domain case, you can easily replace that. And onboarding time with this knowledge graph or knowledge architecture will be very quick. I mean, less than 2 minutes to read the same information. And then another arrow in the bottom, which is the learning capability, which is also a key win factor for this framework is whatever your Agentic AI agent learn from practical actions, the agent should just learn from there and also contribute back to either a new rules of action or new skills or new knowledge. So as the agentic AI agent work with the real world task, it will just enhance this knowledge graph, expand from the out of box language model. So it's kind of real self-learning agent. And then here is just show like how I kind of train this AI agents to be able to link everything. So It's a graph-based retrieval and memory structure that generates the existing graph rag approach beyond entities is relation knowledge to operational and governance artifacts. So the agent's working memory is not just facts, but also procedures, policies, and how they relate when something breaks that we can see why. So here you can see I put some screen capture, which is kind of the auditable tool and visualization to show the result of the training process. At the beginning, when you just throw in those knowledge, skills, and behavior rules, it just scatters dots in the database, and little by little, in the training, it will connect the dots, and that will be functioning as a mind navigation for the Agentic AI to read the information and follow that. So here I will show the actual graph. You can see here, this is the actual graph. You can see the visualization of the brain of the Agentic AI just for the domain knowledge part. So here you can see just for one, I would say Dataverse to ArcGIS Online transformation. This is a skill, and this skill has a sub-skill, which is Dataverse schema validation, and by using Dataverse API, but also the green dot means knowledge. So you can see the by execute these skills, it guided by the production Git workflow, and it have other our departmental documents guiding the skills. And also, there's a constraint called cursor workflow Git. So this is kind of, we do use cursor as like a human AI web coding interface. So there's a certain rules that you have to go with different branch of the cursor Git. So you can see the blue dot is a constraint. So when the agent execute the tools, it will know, oh, I need to follow this certain commit workflow to make a standard for other user in the group to use. So this is kind of a virtualization of how this knowledge graph with three tracks interlock each other and related, and kind of guide Agentic AI to work in a stable way. All right, so this is pretty much how I build the Agentic AI agent in the agent level to make it kind of stable and reach that number 90% roughly for each task in our center. And then I'll talk about like a system trust with multi-agent system. Here is why multi-agent system works, why it can solve error preparation, security coupling, and the lack of individual verification. Continue with the same thing I mentioned earlier about the error propagation thing with a single agent API. So you can see that I kind of expand that through single agent smart data pipeline to multi-agent with auditable handoff. So you can see that it's not just adding isolation agent. By converting a single agent pipeline to multi-agent, the kind of magical thing happen automatically is when you have agent A handling injects and agent B handling cleaning works, instead of transferring model the arrows by itself, there is a handoff between agent A to agent B. When this handoff happening, naturally the next agent will do audit. It will review whatever generated by agent A before it will take action. What's that mean? Back to the simple mathematical proof that 90% to the power of n different steps. When this handoff and audit happen, that means you have agent A has 10% probability to make a mistake. And then another agent will review this, and the chance the second agent will not review the error in the agent A is also 10%. Then this audit happens that will make that 10% tap 10%, which means combine these two agents to work together, the error rate jump from 10% to 1%, is 10% times 10%. So mathematically, we can prove by having different agents work collaboratively when this handoff out happens, you are not transfer the error rate. There's no error propagation, but also by do an audit by different agents, it reduce the chance of making error significantly in this multi-agent system. And also from the security design aspect, we can easily follow which called zero trust security principle of least privilege. Like in our case, we have Avita working as a data curating agent, Story as a publication agent, and Diva as a system administration agent. And all these agents, we just naturally separate them even by operating system level difference. Avita is working on a Windows server and a taking off a data preparation folders. It can have access to metadata files. It has own MCP server, and mainly because our data analyst, data curator, like human workers, they work in Windows machines. And then Story is more like a developer roles. They work in a Ubuntu server. They use CIFS mount, access to the same Ceph storage, access everything through API. So this is kind of the agent work mainly with our developer who deal with more Linux system. And then Diva is more working as a system administrator that also work in a Linux environment, work with production environment with Linux system. Then we don't give Diva capacity for writing code, but Diva have access to the actual production server, actual Ceph storage, actual database. So if anything that Story cannot take care by using APIs, it will send the information to Diva, and Diva will take care. And here is the actual implementation of this kind of collaborative way of working between human worker and AI agent. So you can see here something before I go to details. This multi-agent design is not about adding intelligence, but it's more about adding structure, isolation, and trust boundary to existing workflow. And the MAS wouldn't add for sophistication. Is adding structural checkpoint where arrow can expect it, isolate it, and challenged in each step of your workflow. So here you can see, as I mentioned, Aveta on the Zone 1 in the green label is dealing with data preparation, and Story in the Zone 2 with purple label is dealing with more orchestration, publication. You have a capability as a developer to writing code and generate skills, but is limited to access to repository servers through API. And Diva is the system administration tools, in this case specific for Dataverse, and is pretty much you have the actual access through command line to the actual production environment, to database, web server, Ceph storage, but it doesn't have a capability to execute or generate code as a skill or tools. It will just use command line to actually access the server. So you can see everything start with Enveta to prepare the data package, send over to Story through the MCP. Story will check in the package, audit the result. If everything happened, just communicate back to Enveta, and then Story will continue just process the data, publish to the target platform. In this case, ArcGIS Online for visualization, Dataverse for discovery, Pelican for OSDF data federation. And there's like a some exceptions if the file size is too large for API to handle. For the secure purpose, our API is limited to 100 megabytes. But in reality, a lot of single file, either is satellite image file or there's some video file for underwater marine biology tracking. So those files obviously are larger than 100 megabytes. In that case, Story will send a request through MCP to Diva, and Diva will just take over that task, kind of manually. What I mean by manually is just the AI agent will do a CP command to the actual server instead of using scripts. So this kind of use case or demonstration of how does like multi-agents working with human collaborator to have the current kind of convert the original smart data pipeline to this multi-agent system type of workflow for the MV store data publication in FIU. Here is just some use case. I believe I can show. This is the Envita. I mean, this is for demonstration one, but I think it's okay. I just show this is the internal one, which have the latest work have been done with Enveta. So you can see Enveta have complete 4 major tasks. There's like 849 data sets have been processed. 55 SKUs has been built in the library. Of course, with a human collaborator in the loop, we have to guarantee it's 100% success rate. Otherwise, it won't be in production. So here is just the architecture with there's multiple roles for builder and domain experts and different skills. I won't go too much detail. Oh, by the way, this interface internally built is also for auditing purpose. So we can see what's the written work has been done with the date, and we can check the details. If anything, there will be documents from the agent. This document generated by agent automatically, but as a human collaborator, we can always check if anything is happened. Either expected or unexpected. So that's required still for the human side. And here you can see some major milestones. At the time I do the presentation in the Pelican team, it only done the first one, which is GeoPortal to Dataverse preparation. And after that, we finished the MCP server exchange has been complete and in production. And there's as I mentioned, the 3-track framework has been applied fully. And lately, we just made another complete task, which is we in one of the FIU research group, they're dealing compound flooding, and we just take their work over and we finish the whole publication by using this multi-agent platform. Here you can see this from their publications, some summarize of their work. After publishing everything to ArcGIS Online, we can see the original data has been used and generated from their study by different stations and in the South Florida and also geospatial distributions. Some basic statistic of the data. And also, you can check the result pretty quick For either Pelican, all the data has a Pelican endpoint, and they have executive layer on the ArcGIS Online, and there's also things has been published to FIO Dataverse instance. So I can show very quick. Like this is the master instance of that one. It's automatically generated by the agent, and even with this detail, the metadata. One of the core requirements for this pipeline is this data have to be fire principle compliant. So here you can see it mentioned what is this study about, how many station has it monitoring, and also here I mentioned the actual layers that have been published in ArcGIS Online. Let me go with another. Yeah. If we go to a specific data set, is also list. It should also, yes, it's here, data access. Yeah, it's also list the OSDF endpoint, which are host in FIU Pelican region. That means I know NCAR also have your own account with Pelican OS pool. If you need to repeat the work, you don't need to transfer data. You can just, by following this endpoint and write your own script in OS pool and do some computation work federatedly. All right, so let's go back. Okay, so here I really want to talk about the actual workflow that's inside our department. You is like what I call like AI is a new member. So traditionally, we have developer lead, which is myself, data facilitation lead, department manager, and we used to be the core team. Now with the AI agent in the loop, we just continually collaborate with the AI agent, and also with the knowledge graph we build with the agent. The AI agents recognize the team members. They always check the knowledge source, and they will provide role-specific guidance. So on top of AI agent as a collaborator, it also work as a knowledge carrier. That means for this role in your group or in my group, like if we replace any of this person with another person, instead of we need to provide training in person, the AI agent can give guidance to that person, like rough training about what you need to do, some knowledge you need to get familiar with. Then this collaboration will be like continually improve over the time, and even you need to replace a certain human collaborator, the AI agent will help in that sense as providing essential information, guidance, training to the actual human collaborator. And then this is the kind of the summarization of the current workflow and what's the gaining from our department. What I emphasize, learning is the key. You can see here from the origin phase one, like an initial task, we start analyze the origin task, which is there is a geological data set we are tasked to transfer to our Dataverse. The original step is we only be able to work with agents, scan the original data set, and we only identify like 68 files and be able to publish to Dataverse. So that will take roughly a week, including a lot of detective work with the agent for a legacy data repository. Then after the learning period, and you can see the center column, which is after learning period, we just allow the Agentic AI automatically working with a larger data repository by himself. And then the AI agent, after training with the knowledge, with a skill, with a constraint, it just stably finds 15K files in roughly 2 hours without human interaction. Then we just need to like QA, QC about what is finding. And you can see there's a big improvement up about the outcomes, about the processing times, human hours required. I put 0 hours for processing, but humans still required for Q and QC. And after we do the Q QC things, during the learning period, we do give sufficient knowledge and while develop the tools. At the time we do the QC, the dispatch is reach 100% automated. So this is like a typical loop of the execution of learning in a real world task, and then the agent just improve and execute task by itself. There's some like a production matrix. Just some personal feeling is managing AI easier than human for specific hand-down task. Yes, it does give a good significant improvement because you can actually work with the AI agent at the same time you do the training. So there's no like time lost in terms of communication, and it's easier for agent to redo certain work and generate code on that. So there's some certain metrics, and also I put a specific like example after training. It's not like AI agent just getting better in terms of performance, it getting faster, more accurate, but also it getting more structured. As I show in the box on the top and the highlight is it's actually it was during a late time working session, just me and the agent, and I finished something I really want to push to Dataverse and report is done. And then the agent actually making a plan with different phases and remind me, hey, look, you are the developer role. Based on the knowledge I have, publishing to Dataverse should be a team decision. So it give me a phase two, like decide on processing scale and set quality threshold, and let's wait for tomorrow, checking with the team before you publish. That's something easily happen even to myself, but after training certain things with the agent, it will take this as a constraint and not only constraint to the agent itself, but also come back and remind the human collaborator that, look, this is the rule and the standard of the teamwork, and you better to follow that. So that's what I mean by one aspect that we need for trustworthy agentic AI as a solution in production. All right, so just summarize like what we observed across agent and system layer. First of all, agent level, which I mentioned as pillar one, single agents are reliable only with structure. And pillar two, system level, good agents still fail without isolation. That's why we need to introduce a multi-agent system. And learning over time is important. Improvement comes from artifact, not retraining. What I mean by artifact is like skill and procedure accumulate operationally over with experience, and validation and auditability are required for safer use. Reliability improves without sacrificing the adaptability. So overall, I think trustworthiness emerges from combining agent level structure with system level isolation, not from optimizing either side alone. All right, so this is pretty much what have been done so far with system level solution, pillar one, pillar two. Now there's, of course, this is very new concept. I'm not saying what I'm doing is 100% correct or accurate. I believe there's a lot of things that we can discuss, and there's like open directions. So I'm just throwing some observation from my end for everyone here to think about, and also we can discuss further. So beyond the Stu Helix agent and the multi-agent system, to be very honest, there's still some gaps for this agent to run by itself and to be trustworthy as a independent worker in the whole working environment. The gap including exaggeration validation. Human is still currently arbitrated ambiguous outcomes. Error handling recovery, like not all failure are customizable as priority. So human provide semantic judgment in novel cases. Risk assessment, autonomy thresholds are not yet standardized. So that still require like human involved as a doorkeeper to make sure everything delivered is 100% accurate. And workflow orchestration, of course, like a long-running workflow require rollback judgment, that type of things. So I will say the next challenge is not removing human from the loop, but we need to understand how, when, and where humans could leave the loop, which has not been standardized at this point. So this is kind of, I call that research roadmap, even though my role is implement something for production. But I do notice this require a lot of collaborations and support from different domains. So this is more like a research topic. So at least on my agenda in the next 3 to 6 months, my focus will be understanding human oversight, trying to answer a question like where and why human inverse in revenue today. So I need to focus on instrument human in the loop decision points, formalize exaggeration, validation, and error classification, introduce risk-aware autonomy boundaries, also standardize hierarchical RAG and graph backed memory interfaces. So medium terms, let's say in by the end of this year, I would like to encoding human judgment into artifact, which answer a question like how does human oversight become reusable structure, including skill induction from interaction traces, human guided to agent encoded, SOP induction from repeated human decision, cross-domain evaluation like research data, legal, healthcare, anything I could reach. I'm curious, like from different domain, was whatever I have implemented, is that like a reusable or something need to be added for different domains? So that's really just from curiosity part, and also control the study on artifact-based learning with static prompting. Long term, like 1 to 2 years, I think by the end of 2027, there should be trust-aware multi-agent ecosystem implement in the real-world environment, which the question like where can humans safely step back should be addressed. From my calendar, I think quantitative autonomy budgets and escalate policy should be there. Shared skill repository and inter-agent knowledge transfer should be established. Formal evaluation of emergent coordination and safety properties should be well developed. High reliability development under strict governance constraints should be well defined. So overall, I think this roadmap is not about removing human, but about making their role explicit, manageable, and gradually reducible. All right, the final is just open questions. since we're focusing on human in the loop boundaries, the question will be which decision point require persistent human oversight and which can be safely delegated to autonomous agents. Of course, I want to hear back from whoever working on similar environment, just from your experience, domain expertise, um, regarding those questions like transferabilities and what assumption does the proposed engineer knowledge architecture transfer across domains and where does it break down? What class of safeguard are necessary for provide variable guarantees for agent behaviors in high stakes settings, and also how should agent system balance like continual skill acquisition with the preservation of valid behaviors. Like you want it learning, but how you make sure that the learning will be validated and will not affect the existing stableness. So the central open question is not about autonomy, but also but the controlled transfer of responsibility from human to agents. So last part is kind of just the vision. When I talk about this vision with GPT, I asked GPT to generate this kind of prediction of how workflow and roles will be shifted in 2 years. So if we look back about 2023, it's still very traditional, like junior developer, data engineer, DevOps specialist. And now it's not 2025 anymore. We're 2026. But when the agentic system engineer in place, the role has been shifted to AI augmented developer. I believe a lot of developers do not even type code anymore. You work with like web coding type of agent. It will generate code for you. Multi-agent architect, LM governor, psycho AI collaborator type of role. And I'm kind of seeing in year of 2027, there will be a trust-centric human AI ecosystem. So the role will become distributed trust supervisor, human AI collaborator designer, AI-driven safety auditor, autonomy policy developer type of role. Not too far ago, like next year. I believe something going to happen in this direction. So that's pretty much about today's talk. Hope I'm not go over too much in terms of the time. And thank you for your time and listening. Any questions about my talk?
All right, thanks, Kevin. Let's give him a quick round of applause. Have you gone through this process? You've learned a lot. Have there been any areas, where you've seen, wow, that could be catastrophic if we don't have trusted AI as you've gone through this workflow and put in, bumpers and checks and balances?
I'll give a quick one, just at the very beginning. Like I'm trying to have a system administrator, which is Diva I just presented, and there's sometimes in Linux, agent is struggling with directory. So there's one time I think it's pretty straightforward just to do a auditing work with the database entries and general statistics. So I leave it run overnight. That's like early September last year. I'm kind of very optimized about the agentic AI, so I leave it run overnight. So second day when I come back, it really surprised me. Like the whole interface looks different and the data looks different, and I just track back when I see is the agentic AI means a slash and go to a wrong directory. And the agent scare himself like, wow, everything disappear. There's no system, there's no data. And he just mentioned like, I must do something wrong and I really need to fix this. And then the agent, based on the wrong directory, rebuild the whole system. He just download the, at that time I give too much open capability to Diva. So Diva just from GitHub download a brand new Dataverse, implement in that directly, create a new application and deploy the old one, implement this one, and even based on its memory, making up all the data and give a new system similar to the old one. And that's one pretty terrifying use case that I noticed that, oh, it cannot be like that. We have to do something that otherwise the AI agent can do something really cause my heart attack for whoever work in the production project.
So I was, let's say, curious about how you're using large language models to clean data. And I read your paper, and it seems like you're using LLMs to replace bad data. So I guess my question is, do people contributing data sets know that you're using LLMs to fill in data? And do publications who use data on this system disclose that it's been edited with large language models?
Is very good question. That's I know that also I will say simple short answer that depends. Mainly because the workflow is MA as a project is a platform. We work with research group in FIU, which is over 30 groups, and we keep emphasize that at the first like onboarding process, our data facilitator need to talk with the actual research group, and we need to be very clear about the data agreement that each research group has with the actual data owner, and that's like the required documents for data onboarding. Then this actually the data agreement, like a contract or amendment, will become a knowledge to the language model. Of course, if it make it clear that the data owner do not allow the data to share anywhere other than FIO server, either will consider to use a local host open source language model, or that may not be feasible for this platform. But that's all really depends on the initial onboarding or facilitation process, even before bringing their data into MSTOR platform. I hope that answered your question.
Yeah, mostly. Thanks.
All right. Well, thanks again, everybody, for joining and taking time. And I think we'll be planning another seminar for February. And thanks again, Keven, for giving your time today. We really appreciate your talk.
Thank you. Thank you for the invitation.